In this video, I'm going to talk about the parent function for sine. The parent function for sine is y equals sine of x because that is the most basic sine equation. It has no extra stuff. In order to graph this parent function, I'm going to fill out this table below. So in this table below, I've given angles that I want to input. From the unit circle. I'm going to convert those first to degrees. Those angles, I'm going to convert them to degrees, just in case it's easier for you to look at these things in terms of degrees, since we're still just starting out using the unit circle. And then we're going to see when we input those angles, what are we going to get out for y? So first I'm going to look at the angles I know from the unit circle from 0 to 2 pi, and I'm going to convert those to degrees. I know 0 radians is going to be 0 degrees, pi over 2 radians is going to be 90 degrees, pi is going to be 180, 3 pi over 2 is 270, and then 2 pi is 360 full circle. For pi over 4, or all the other angles that I see they all have a reference angle of pi over 4 because they have 4 in the denominator. I know that if I have a reference angle of 4 or pi over 4, then I know that the reference angle is 45 degrees. For pi over 4, that's in the first quadrant. For 3 pi over 4, that's in the second quadrant. 5 pi over 4 is in the third, and then 7 pi over 4 is in the fourth quadrant, and they all have a reference angle of 45 degrees. If I'm in quadrant 1, that means that my angle is the same as the reference angle, so it is 45 degrees. If I have an angle in the second quadrant with a reference angle of 45 degrees, then I take 180 and subtract 145 degrees, and I get 135 degrees. If I'm in the third quadrant with a 45 degree reference angle, I know that I'm doing 180 plus 45, which is 225. And then if I'm in quadrant 4 with a reference angle of 45 degrees, I know that I do 360 minus 45, which gives me 315 degrees. Since sine is and this is sine, and that's an odd function, I know that if I were to plug in pi over 4 or 45 degrees, whatever I would get from that, I would just be able to change it to its opposite for these angles on the left-hand side, which is what I'm going to do when I'm talking about the outputs. But for right now, all I'm going to do is write these values that I have for positive degrees, and I'm going to write them negative. So I have negative 45 degrees here, negative 135, negative 225, and negative 315. And then I have negative 90, negative 180, negative 270, and negative 360. And then I'm going to go from there. So the first thing I'm going to do is I'm going to find what my ratios are when I plug in these angles into my sine function. And I'm going to do the ones that start and end each quadrant because those are easier. So I have, if I'm doing 0 degrees or 0 radians, I'm at the point 1, 0. So I'm at the point 1, 0, and I want to look for my sine of theta, which would be my y value, in those points that come from the unit circle. So first of all, my x is theta, so I'm thinking sine of theta, but right now I'm thinking sine of x. I'm just going to write theta so we don't get confused, and I know sine of theta is always my y value in the points that I'm looking at from the unit circle. So if I plug in sine and I do sine of 0, I'm going to get out 0. If I do sine of pi over 2 or sine of 90 degrees, I'm going to be at the point 0, comma 1, and my output would be 1. If I do sine of pi, I know that I'm looking at the point negative 1 comma 0, so my output is 0. And if I'm at 270 or 3 pi over 2 and I do sine of that, I'm going to be at the point 0 comma negative 1, and my output is negative 1. And then if I do sine of 360, I'm back here, and my y value in that point is 0. Then I'm going to do the reference, the ones that have a reference angle of 45 degrees. So in the, when I have a reference angle of 45 degrees, I know I have some variation of the point square root of 2 over 2, comma square root of 2 over 2. And so my y value is going to be positive or negative square root of 2 over 2, which I'm going to simplify to 0.7. If I put that in my calculator, that's what I would get. If I do that, then I know, or if I think about it like that, then I know if I'm in the first quadrant, my y value is going to be positive. So I know my y value is positive. I guess I'll write it like this. Like that. I know my y value is positive, so it's going to be positive 0.7 or positive square root of 2 over 2. My y value in the second quadrant is also positive, so I know that I'm going to have another positive 0.7 as the output. For quadrant 3, I know my y value is negative, so I'm going to have negative 0.7. And then in the fourth quadrant, I know my y value is negative, so I'm going to have negative 0.7. From there, I'm going to fill in the rest of my table based off of what I know about sine. I know sine, like I said before, it's an odd function, which means that if I were to plug in the positive version of the angle and then the negative version of the angle, I would get the opposites. So if I plugged in positive pi over 4, then, and I got 0.7, then if I plugged in negative pi over 4, I would get negative 0.7. If I plugged in positive pi over 2 and I got 1, then if I plugged in negative pi over 2, I would get negative 1. If I plugged in positive 3 pi over 4 and got 0.7, then if I plugged in negative 3 pi over 4, I would get negative 0.7. And then I keep going. So I have negative 180 and 0, negative 225 and positive 0.7, and negative 270 and positive 1, negative 315 and positive 0.7, and the negative 360 and 0. Then I'm going to plot these things on this graph below. And what I want to notice about the graph below, and this is going to be true for all sine graphs, is that the x-axis is in radians, and that is always going to be the case when I'm graphing cosine and sine functions, so I need to make sure that I'm going to label my x-axis in radians. Even if you think about things in terms of degrees, you should really get used to just thinking about things in terms of radians, because that's where we're going to be using for all of the graphs that we do in this unit. First thing I'm going to do is I'm going to take the ones that are on the x-axis, the points that are on the x-axis, and I'm going to graph those. So I have 0, 0, I have pi is 0, and I have 2 pi, 0. I also have a negative pi, 0, and negative 2 pi, 0, and I'm going to put all those on my graph. So I have 0, 0, I have pi, 0, and I have 2 pi, 0. Then I have negative pi, 0, and I have negative 2 pi, 0. The next thing I'm going to do is I'm going to focus on what I have ones and negative ones. So I'm going to focus on those points. Those are going to be the tops and bottoms of my sine graph. They're the maximum and minimums. I have those maximums and minimums at pi over 2, 3 pi over 2, negative pi over 2, and negative 3 pi over 2. I'm going to plot those on my graph. So I have the point pi over 2 comma 1. I have 3 pi over 2 comma negative 1. And then I have negative pi over 2 comma negative 1. And negative 3 pi over 2 comma positive 1. And then I'll go in with all the ones that have going back and forth between 0.7 and negative 0.7. And for those points, those are all the ones that have a reference angle of pi over 4. And I'm going to plot the ones on the right first. So I have pi over 4 comma 0.7. Pi over 4 is in between 0 and 2 and pi over 2, so it's here, and there's where my point is. Then 3 pi over 4 comma 0.7, that's in between pi over, so 3 pi over 4 is in between pi over 2 and pi, so it's there, and I have a point here. Then between pi and 3 pi over 2, I have 5 pi over 4, and I have negative 0.7. And then between 3 pi over 2 and 2 pi, I have 7 pi over 2, which is also negative 0.7. And then I'm going to just continue on the other side. All of the ones that I have are halfway in between the ones that are scaled on the x-axis. So this is what my graph is going to look like. It's going to look like a wave. So I wanted to include that 0.707 point. I could see that everything was going back and forth. But I need to know that it's not straight lines, it's in curves that this is happening. If I were to continue this pattern, I see a pattern continuing. I know that at 5 pi over 2, I would have another point at 1. So this is how the pattern would continue over and over, and I see a wave. And this is what my sine graph is going to look like. The thing that I see repeating, the shape that I see repeating over and over is an S shape. This, I remember this is it looks like an S shape that's repeating over and over because it is sine, so it starts with an S.